problem for you here from Randolph High School. Now let me write down something I forgot to write down right now. It just comes from the problem statement. Okay, we have a quadratic expression with a pair of distinct real zeros, real roots, some people call them. And the two zeros, we're going to give them names, call them m and n. We'll arbitrarily say m is larger without loss of generality, right? And so we get m minus n is equal to 5. Now this, again, this is a Randolph High School competition problem, and I don't know where Randolph High School is actually. There's more on that at the end of this video. But in any event, you can rewrite this quadratic. We're trying to find the value of a. A is given to be a positive real number. You can rewrite this equivalently like this by just subtracting x plus a from both sides, right? Now we dividing through by a turns out to be quite useful for comparing things here with the roots. Now notice that if you have m and n as roots, they correspond to factors. Any root corresponds to a linear factor. That's just the factor theorem. It's very straightforward to believe that. And this very next step is when you multiply all of this out, you see you have x times this, x times minus m, and then minus n times x. They combine to give you this minus m plus nx as the coefficient of x, right? Now, what makes this helpful right here is notice we can rewrite this term as minus 1 over a times x. Minus 1 over a, and that's my crippled looking a, folks. Doesn't look anything like the a above it. All right, but notice that means that minus 1 over a, which is the coefficient of x over here, has to be equated with this coefficient right here, and that's why we did this. You see, again, coefficient of x right here, coefficient of x right here, we equate the two coefficients, and you get m plus n is equal to 1 over a. Okay, this is m minus n is equal to 5, and this is really the key step for me. Just to write this down and go to here was maybe the biggest step of the problem. Now also, since the minus signs, these two minus signs cancel, the mn is left as the constant term, which is the product of the roots. Okay, so we get these three equations and three unknowns. Oh, and I lied to you. This was actually the hardest step for me to see, because where did this come from? Well, notice that if you multiply this equation by m, and I just didn't notice that, it's pretty simple really in retrospect, but if you multiply this equation by m times m gives you m squared, right? Then m times 5 gives you this 5m you see right here. Now here's the kicker. If you multiply this by m, you get minus mn, but minus mn is plus 1, right? Since mn is minus 1. So that's where this plus 1 comes from this minus sign multiplied by this minus 1, right? Kind of cool. Now from there you quickly get a quadratic that, and I won't go through this. This is, if you bring the 5m to the other side, you get minus 5m, and the quadratic will give you this. Notice you would have minus 5m over here, you'd have equals 0 here, so the minus sign would kill off and give you a plus 5 right there. Now we keep the positive solution, or the largest solution, excuse me. You could work with either of them actually, but remember we chose m to be the larger one, so we'll keep m is the largest positive value. Now the rest of this is kind of fun also. Notice that right here you can this says m plus n, right? But this means you can rewrite this as n, okay, is equal to m minus 5. Okay, n is equal to m minus 5. Okay, folks. Now you can, I guess you can see why that's important. Okay, because right here we have m plus n. Well, this part is n, but this would be m minus 5 right here, right? See, m is this guy right here, but n is equal to m minus 5 from this statement, and that's exactly what happened here. So that's kind of cool. I like that a lot. Now, also, we have half of a thing plus half of a thing. Okay, well, let's see, what is that equal to? That's equal to the whole thing, right? So you would have 5 plus root 21. I'll just write this out. It's probably unnecessary, but 5 plus root 21 happening twice, right? Or just let me just write it down like this. 5 plus root 21. Again, y'all know this sounds silly. You probably don't need any explanation at all, but half of something plus half of something is the something. Now you still have the minus 5, right? Okay. But that is just equal to root 21, okay, which is equal to 1 over a. So that's equal to root 21. And I think I have this on the next line, but I just want to write it down here. So root 21 is equal to 1 over a. Okay. And on the very next line right here, you'll see that we could finish it off. So root 21 is equal to 1 over a, and this is our solution. A is equal to 1 over root 21. Now, a gentleman by the name of, and I'll show you this. This is what I wanted to show you at the very end. This gentleman, David Altizio, I guess, created this problem for this RHS Guts Round 2015. And he wanted to know what a squared was for whatever reasons. You know, maybe he had a clever way of finding that without going to all the trouble I've gone through. So the actual answer here would just be 1 over 21 if you were looking to answer his question. And perhaps there's an easier way, I'm suspecting there is, of getting to a squared, because what I did up here was perhaps a little more work than they intended for the high school math competition. I'm sure he had some clever way of figuring out what a squared was without going through all this. But in any event, I did determine what 1 over a was. All right. And no, wait a minute. That's not right. 1 over. So a squared would be what? A is, this is 1 over, let's see here. That's right. Yeah. If this is equal to a, then a squared is equal to 1 over 21 was the answer to the question in the competition. But anyway, thank you to David for composing this problem. I liked it a lot.